Today we're going to do 2.3 part 2. So we already did the first half of our notes on getting information from a graph. So everything on here you should already have written down in your own notes. You're welcome to continue using the guided notes from Google Classroom because we are going to move down to local maximum and minimum notes and then do an example together. I do want to back up just a little bit and go over the 2.2 homework. So even if you got a 5 on it, there were some things I didn't take off for, so I want to make sure everybody understands this. So even if you got a 5, please go get your 2.2 notes your 2.2 homework and go ahead and update it, or just write this in your 2.2 notes in a little spot, like on a sticky note or something, because I do want you to get this information. So a couple things is it didn't seem clear to me that people were using Desmos or a graphing calculator to check their work. So you need to check what a graph looks like on Desmos or a graphing calculator in order to make sure you get the scope, the entire drawing, the entire scope of the graph in your picture. Another thing is you have a graphing calculator on your Chromebook. That got downloaded to your Chromebook this year. So everybody has access to a TI 84-ish graphing calculator on your Chromebook. Go find that application. Also, Desmos.com is pretty straightforward as well. So let's go look at some of these hints down here for the homework. So this was your homework a couple days ago. So let's look at number 1. It's an absolute value function. If I plug this into Desmos or a graphing calculator, I will get a V-shaped graph, and it stops here. And you need to figure out what that vertex is, okay? And I believe that vertex is over here in the negative somewhere, and then it goes up like this. I'm not certain exactly, but whatever that vertex is, that is the bottom of your range. Your range only goes from that value upwards, okay? So your range is going to be affected by that number. Your range is only going from infinity and then that exact number that you guys need to find in your vertex, okay? And then you also still need to make your XY graph. But it's really important to find that vertex and to understand what the graph looks like, okay? Some of you are making it curved, which is fine. That's an x squared function, though. We are doing an absolute value function, so you need to use your graphing calculator to understand exactly what it looks like, okay? Number 2, so this is another one that people were confused about what the actual graph looked like. A lot of people did this and then just finished there because they only plugged in points in their XY graph in between here. But if you plug it into a graphing calculator, it looks like this and goes on forever this direction, okay? So actually, you need to go look at a graph of it before you start plotting so that you know that you actually need to continue plotting until it goes back down. So that will affect what your graph looks like, and it also affects your domain and range, okay? Which in this case, your domain goes forever in the negative direction and forever in the positive direction, and that's the same with your range. Okay, which is different from what a lot of you guys had, okay? So make sure to double check with a graphing calculator first. Okay, then number 3. This one also, a lot of people got it correct. It looks something like this when you plug it into a calculator, okay? And then you need to figure out what this point is because it's very important that's where your x, somewhere over here, I think it was like -4 1/2 or something. Whatever this point is, you need to figure that out because if it's over here, -4 2, I think is what it was. That spot right here, this -4 2, is the limit to both your domain and your range. So your domain stops at -4 and goes forever in the positive direction, and your range only goes to -2 and then forever in the upwards direction, okay? So you need to make sure you have those exact numbers right there. Same with number 4. You guys graphed it correctly. It looked like this, but this vertex is very important to get as your last number because you need it for your domain and range to be accurate. So a reminder that vertex can be found by -b/2a. So that's an old information. So if I take this equation, negative b over 2a is negative 6 over 2 times 2, which is negative 3 over 4. Actually, sorry, that's negative 3 over 2 is your vertex value. That's going to be your x value. And then you need to plug that into the equation to get y. And I think your y value is going to come out to be 1/2. Or something like that, like 0.5 or 1/2 or negative 1/2 or whatever. And that really affects your range here because that is the limit to how far down you can go in the negatives, and then it goes up to infinity in the positives. So just to make sure you check for the specific vertex because that is the lowest value of the range in this equation. Okay, and then one more note, this piecewise function really messed people up. Although they got the graph correct, there was issues with the chart. So here's one thing that I just need to make sure everybody gets, and I didn't clarify it enough last time. So there's 3 parts here. There's 3 functions going on. There's f of x equals 4, f of x equals x squared, and f of x equals negative x plus 6. So we need to split this into 3 parts, okay? And we need to look at this value where it switches to the next function. So at negative 2, it stops being this first function and jumps down to the next function down here, okay? So we actually need, this is going to be our first function. This is f of x equals 4. This is f of x equals x squared. And this is going to be f of x equals negative 6x plus 6, okay? We need to have negative 2 right here on both sides because that's the switching point between those 2 functions. We also need to have the next switching point is at 2, so we need to have 2 on both sides here. And then we need to decide which one is an open circle and which one's a closed circle, okay? So I'm going to fill in some of the spaces in between. So this is going to be negative 3, negative 4. This is negative 1, 0, 1, and this is 3, 4. And then all the answers here are f of x equals 4 every time. And then the next one changes. This is 4, 1, 0, 1, 4. And then this is f of negative x plus 6. So negative 2 plus 6 is 4, negative 3 plus 6 is 3, negative 4 plus 6 is 2. Okay, so now we need to decide what the open circle is. So this one, we need to decide between these two. Okay, well, the top one is a less than negative 2, so it doesn't include negative 2, so this value is going to be an open circle. And then this one, the second function includes negative 2, so it's going to be a closed circle. And then this 2 is a closed circle because it's included in that function and it's not included in the next function. So that's what you need to graph. Luckily, these actually are the same value, x, y, so when you plot those, let's plot it, negative 4 up 4. Negative 3 up 4, and negative 2 up 4, but it's an open circle, okay? And then we switch to the next function. Negative 2, 4, closed circle, so I'm going to draw it inside. Negative 1, 1, 0, 0, 1, 1, 2, 4. 2, 4 is another closed circle, and then the next 2, 4 is an open circle on top of it. So luckily in this case they kind of overlap, so everything is covered here, but sometimes they don't overlap and you have to jump to a new spot and put an open circle there. So it's really important to tell where the open and the closed circle is. So your graph is going to go forever this direction, 4, 4, 4 in the negatives. It's right here. And then it's going to go forever in this direction because that's a linear function, okay? So it's very important to, my point here is to put the x value where it shifts to the next function on both functions and decide where it's an open circle and where it's a closed circle. And a lot of people didn't do that, so you need to go back and fix that. All right, we're going to jump to our guided notes and do our local maxima and minima notes. So if you want to go to your guided notes, this is the second part. We're halfway down the second page. Okay, we're at the spot that says local maxima and minima notes. So the function value f of a is a blank of f if f of a is greater than all the f of x around it, where x is near a. So that's really complicated, but that's how definitions are written in math. So let's just make some marks here. Where x is near a, this is just a general open interval. So let's rewrite this in our head. In a general open interval, like a general rectangle of space, the function f of a is a blank if f of a is greater than all of the f of x around it. So if f of a is greater than everything around it, it is a local maximum value. So if f of a is greater than all of the f of x's around it, okay? So we would say f of a has a local maximum, you can say it, f of a has a local maximum at x equals a. Okay, and then on this graph over here, these are two local maximums. Even though this one is higher than this one, it doesn't matter. In their relative area, like in this relative spot, this one's a local maximum, and then in this like relative spot, this one's a local maximum. Okay, so those are our local maximum points. And then a similar definition for the other one. Oh, sorry. Okay, a similar definition for the other side. The function value f of a is a blank if f of a is less than or equal to f of x around it, where x is near a. So this is also just like a general open interval. And if f of a is smaller than everything around it, then it is a local minimum value. Okay, and we would say that as f has a local minimum at x equals a, at that value, okay? So our local minimums are these two, okay? Again, although this minimum is much higher than the other one, it's in its relative area, it's the lowest spot because everything right around it is higher than it. So that's kind of the point of a local minimum. It's just a local minimum in a local area. It's a minimum. Okay, another quick note is that this over here is not a local minimum. Anything on the edges of a graph that you don't know what comes next, like does it keep going down or does it go straight up? Like maybe if it goes straight up, then yes, that's a local minimum, but we don't know. So that side value cannot count as a local minimum. And then this side value over here in the same way cannot count as a local maximum because we don't know if it goes up or down from there. So don't count those. All right, we have an example here. Example 8, find the local maximum and minimum value of the function f of x equals x to the third minus 8x plus 1, round to 3 decimal places. So you need to use Desmos or a graphing calculator on your Chromebook. Everyone has it installed. And you need to plug this equation in. And the first thing you'll notice is that the graph looks like let's see, 1, 2, 3, 4, 5. And then you'll notice that the graph looks something like this. And just from looking at the graph on your calculator or on Desmos.com, you'll know that it looks like there is a local maximum somewhere between, remember we're just referring to the x values here. So there's a local x, a local maximum, so in this general area it's a maximum, at x somewhere between x equals -1 and -2, and local minimum between x equals 1 and x equals 2. So that's our general observation right away. So that's our local minimum, but we don't know the exact value. So you need to go to Desmos.com, and as soon as you plug in this equation, you'll see this shape, and you can just click on this point up here, and you'll get the local maximum. You'll just say the function has a local maximum, and right now all we want is the x value at x equals, I think it's -1.63. Okay, and then we write the same thing, and a local minimum at x equals 1.63. Okay, so that's your answer there. Now, you need to go check that you can do that yourself. Go on Desmos.com, make sure you can drag the mouse around. When you drag the mouse up and down, it actually gives you all these points in between here. So if you can drag your mouse around, it gives you points as you drag it onto the graph, okay? Also, go on a graphing calculator, plug that into the graphing calculator, and then click the trace button, and it does the same thing. You push the trace button, and then you can follow all the way up and around the graph, and it gives you XY points as you go. Okay, so if you need any help with that, please reach out. Don't wait until a quiz or test day.